All right, folks, we're back and we're going to review for your third exam today. The third exam will cover periodic properties as well as bonding. So let's just jump right into it. The first half of our review will be periodic properties. So one of the most important periodic properties is that of atomic radius. So on question number 1, I want you to rank these elements in order of increasing atomic size. So we have sulfur, germanium, phosphorus, and sulfur, and I want to rank them from small radius to big radius. So let's find those 4 elements on our periodic table: sulfur, germanium, phosphorus, and silicon. Sulfur, germanium, phosphorus, and silicon. There they are. And remember, when you move across a period, any given period, the atomic radius decreases. Now you need to know why it decreases. As you recall, when you go across a particular period, you're not gaining any energy levels. Yeah, you're gaining electrons, but they're all being gained on the same energy level. But inside the nucleus, you're gaining protons. And that positive charge, the increasing effective nuclear charge, is pulling those electrons in closer, also increasing the ionization energy, which we're going to talk about in a bit as well. Now when you move down a group, the radius increases, and that's because you're gaining energy levels, so you're physically farther away from the nucleus. But in addition to that, the inner levels are pushing out the outer levels. The shielding effect kicks in, so those inner electron layers are pushing away those outer electron layers, increasing the radius. So it looks like we have 1, 2, 3, 4 energy levels for the element germanium, and sulfur, phosphorus, and silicon only have 3. So the largest radius is going to be germanium, so I'm going to put that one at the end. Okay, and then if we take a look, if it decreases when I move to the right, that means sulfur will be the smallest, silicon will be the next largest. So I'm going to put silicon there, and then we would have phosphorus and finally sulfur. So phosphorus and sulfur. So from smallest radius to largest, sulfur, phosphorus, silicon, and germanium. All right, on this review I want to change something for number 2. It says arrange the ions, Na+, K+. This should be Cl negative and Br negative. And I want to put those in order of increasing size. Once again, this will be their radius, not their mass. So we're going to start with small radius again, and we're going to go to big radius. So let's find those on the periodic table. Let's go ahead and clear this page. We are going to work with Na+, K+, Cl negative, and Br negative. So when we deal with ions, we've either lost or gained electrons. So let's figure out how many protons and electrons each of these ions has. Let's start with chlorine. You would agree it has 17 protons. Its atomic number is 17. It's -1, so it's gained an electron. So it has 18 electrons. Bromine has 35 protons, and it's also gained an electron, because it's Br negative, so it has 36 electrons. Okay? All right, over here on this side we have sodium, and sodium has 11 protons, but it's +1, so it's lost an electron, so it only has 10. And potassium, its atomic number is 19, so it has 19 protons. It's also lost an electron, it's +1, so it only has 18 electrons. So if we just look at the proton to electron ratio, it looks like for my negative ions, I have more electrons than I have protons. And for my positive ions, I have more protons than I have electrons. Well, that's going to be a bit of evidence. That's going to help us figure this out. We can also count energy levels. Looks like we have 1, 2, 3, 4 energy levels for, well, Br negative, 3 levels for Cl negative, and Na+, since it's lost an electron, it has 10 electrons. It would be like neon with 10. And K+, since it's lost an electron, would have 18, and so that would be like argon. So just looking from an energy level perspective, it looks like Br negative is going to be our largest because it has 4 energy levels. So I'm going to go ahead and put Br negative over here as my largest ion. And Cl negative, let's see, it will have 3 energy levels. K plus is like argon, it has 3 energy levels. So now we're going to look at the proton to electron ratio. Looks like in K plus I have 19 protons to 18 electrons. More positives than negatives. And in Cl negative I have 17 protons and 18 electrons, more negatives than positives. So those that will allow it to expand a little bit. So Cl negative would be the next largest. And then we just need to choose here between K plus and Na plus. So K plus, like we said, has 3 energy levels because it's lost an electron, only has 18 like argon, and sodium plus has 10 electrons like neon. So K plus has 3 energy levels. It would be the next largest, and the smallest of that group would be Na plus. Okay? All right, next up, I want to rank these guys in order of increasing ionization energy. So low ionization energy to high ionization energy. So let's clear off our periodic table here, and let's find the elements we're going to be dealing with. We have beryllium, calcium, nitrogen, and phosphorus. So we have beryllium, calcium, nitrogen, and phosphorus, and we're doing ionization energy. So you might recall when you move to the right across the period, ionization energy increases, and that's due to an increasing effective nuclear charge. The radius is getting smaller and it's going to hold those electrons more tightly. When I move down a group, the ionization energy decreases. That's because we're gaining energy levels. Those electrons are farther away, and the inner levels are pushing out those outer levels. They're repelling them. So which of these is going to have the lowest? Which one's going to be the easiest to take an electron from? Looks like the one with the most energy levels. So calcium has 1, 2, 3, 4. So calcium would have the lowest ionization energy. Next up, we have either phosphorus, nitrogen, or beryllium. Now, if I just look at the periodic table and make a prediction, phosphorus has 3 energy levels. Beryllium has 2, and so does nitrogen. So these electrons are physically farther away, and they have more shielding. So I'm going to say phosphorus would have the next highest ionization energy. And then I have beryllium and nitrogen. Beryllium is a larger radius than nitrogen because remember, as we go across, the radius decreases. So nitrogens are held more tightly than beryllium. So I think beryllium would be next, and then nitrogen would have the highest ionization. Once again, if I'm just looking at their position on the periodic table, I probably want to look and find out for sure which of those was higher, but that would be my prediction. Okay? All right, number 4, which of the following pairs would have the higher electron affinity? So electron affinity is the ability to attract a non-bonding electron. So on letter A, I'm going to make another change here. This is Cl or Cl negative. That should be the chloride ion there. So let's go to our periodic table, and we're going to find Cl. It's right over here, and Cl negative. So Cl has 17 protons and 17 electrons. Cl negative has 17 protons and 18 electrons. So which of those is going to have an easier time attracting electrons to itself that are non-bonding? Yeah, probably the one with the lower number of electrons, since they have the same number of protons. So I'm going to go with Cl having the higher electron affinity. Okay, next up, sodium or potassium. Sodium's right here. Here's potassium. So sodium has 3 energy levels. Potassium has 4. It'll be easier for the one with fewer energy levels to attract electrons to itself, so sodium would have the higher electron affinity. And then finally Br or I. So Br is over here, I is over here. Once again, Br is smaller. It'll have an easier time attracting electrons to itself. So those would be my 3 choices for question number 4. Okay, question number 5. Now we want to go ahead and answer a few questions. A lot of this uses vocabulary, and some of it uses electron configurations. So let's see how we do on this. First of all, let me clear off my periodic table so it's not so claustrophobic there. And let's go back to our review. Letter A wants the smallest alkaline earth metal. Do you remember where the alkaline earth metals are? If you said group 2, you are correct. And so the smallest alkaline earth metal would be beryllium. It only has 2 energy levels, so I would say Be. Okay? All right, the electron configuration at the end would be 3d10 4s2. Sometimes this is written as 4s2 3d10. And I didn't write the noble gas that comes before it, so I better clean that up a little bit. The noble gas that comes before that would be krypton. So it would be krypton 4s2 3d10. So let's see what that is. Here's krypton, right? And, oh, sorry, I made a mistake there. It's not krypton. The noble gas I want is argon. My bad. So we would have argon 4s2 3d10. So here's argon, and we have 1, 2, 3, 4. So 4s2 would get me to calcium. And then remember, this is the D block, and it's always 1 behind the row number. So this is 3d1, 3d2, 3d3, 4, 5, 6, 7, 8, 9, 10. So it looks like the answer here would be zinc. Okay, the next up, the halogen with the lowest ionization energy. So where are the halogens? Well, the halogens are in group 17, and the lowest ionization energy, that means the one that's easiest to take an electron from. So that's going to be the one with the biggest radius that has the most shielding, and that would be astatine. So I would choose astatine for 5C. Okay, next page has 13 more electrons than argon. So let's find argon. Argon is right here. It has 18 electrons. And if I want 13 more electrons than argon, that would be 31 electrons. Atomic number 31 looks like it's that guy right there, gallium. So I would choose GA. Letter E, the smallest nonmetal, and when I say smallest, it's not by mass. I'm talking atomic radius again, folks. So let's see, smallest nonmetal. So I'm going to draw my line in here. Doesn't the nonmetal line go right over here? And the radius decreases when you go to the right. It decreases when you go up, so I'm going to pick helium. So helium would be the nonmetal with the smallest radius. And letter F, the group 14 element with the highest or largest ionization energy. So group 14, that's carbon family, and I want the highest ionization energy, so that would be the smallest member of group 14, because the electrons are closest to the nucleus, and that would be carbon. Letter G, I want to change this to the 2+ ion instead of the 3+ ion. So this guy will have the electron configuration of krypton 4d10. So that's interesting because I'm missing something right here. Well, let's see. Krypton, wouldn't it be 5s2 4d10? And then if it's 2 positive, I would lose the valence electrons, which are the 5th energy level in this case, and so they would go away. So it would be the neutral element whose configuration was krypton 5s2 4d10. So krypton 5s2 4d10. Here's krypton. Here's the fifth row, 5s2, and then this is 4d10. That would be cadmium. So cadmium would have, cadmium 2 plus would have the electron configuration krypton 4d10. Once again, the 5s2 electrons, they were lost, making it 2 positive. Okay, let's finish up number 6, and then we'll quit for part 1, and we'll do bonding for part 2. So I want the group and period number for the following elements. So we're going to do phosphorus. Let's not do that. Let's clear the page on the periodic table, and we'll number our groups and periods. If you remember, the groups are the columns. Then there are 18 of them. 10, 11, 12, 13, 14, 15, 16, 17, 18. And the periods are the horizontal rows, and there are 7 of them. I'm only going to do, looks like Mr. Hummer's having a hard time counting here. I said 7, and I wrote the number 7 down by mistake. So 1, 2, 3, 4, 5, 6, 7. We're just going to do phosphorus for you. The rest of them should be pretty simple. Don't you agree that phosphorus is in group 15? And it's in period number 3. So phosphorus, group 15, period 3. And I think you guys can do the rest of these on your own pretty easily. Okay? Now when we come back for part 2, we're going to be drawing Lewis structures, figuring out valence electron shape, bond angle, and polarity. That's the second half of our unit. So we'll see you soon. Bye-bye.